Okay, so we are going to start on the on your own that you guys did on your own at home after class Tuesday. On 6-2, the question was asking us basically if you started with 1256.0 moles of the iron ore, how much oxygen would you need and how much Fe2O3 would you make? So that's the question in moles, okay? So we need the moles of each of those. So this is just comparing moles to moles, which comes from our equation. So we'll start with what we know, and we will multiply it by the relationship. So if I'm looking for oxygen, I'm going to go back and look in the equation, and I see the relationship is 4 of the FeS2 for every 11 oxygen. So 4 of the FeS2 goes on bottom, 4 moles, for 11 moles of O2 on top. I take 1256 times 11 and divide that by 4. And I am going to get 3,454.0. I do want to keep all 5 sig figs because that's what I started out with, and we don't look at the ratios, the coefficient. We don't consider the coefficients there as sig figs, okay? So 34540 moles of O2 would be our answer, okay? All right, so now we want to find the other one. We start with what we know again. And we are going to times it by a different ratio this time because the way these two compare is it's 4 of our iron ore for every 2 of that. So we're still going to have this 4 moles of FeS2 on bottom, but we only have 2 moles of the Fe2O3 are made with that. And so we're going to take 1256 times 2, divide it by 4, and the answer we get is 628. We do want 5 sig figs, so we're going to actually write that as 628.00 moles of Fe2O3, okay? So that is the first example. On your own 6-2. Now, on your own 6-3 is next. On your own 6-3, we had this citric acid recipe, and we were starting with 1.4 times 10 to the 5th moles of citric acid, okay? That was the C6H8O7. And we wanted to know the minimum amount of the reactants needed. And so basically we're just gonna say how many moles of all the things that we mixed up, how many moles of C12H22O11, how many moles of H2O, and how many moles of O2. So we're going to find all 3 of those, okay? That's my question. Question. So we're going to have to look for 3 things. So we start with what we know, the 1.4 times 10 to the 5th moles of C6H8O7. We go to the equation because we're going to find this one first, the C12H22O11. And so we go look at our equation in there, and there's 1 of the C12H22O11 for every 2 of this one. So it's 2 of these for every 1 of this one. We're going to stick that in. The one we're looking for, C12H22O11. So basically you're going to have 1.4 divided by 2, and that's 0.7 times 10 to the 5th We do want to write that though in scientific notation. So if we move that one way, we're making that number bigger, so we make that one smaller. We do need 2 sig figs though, so let's make that 7.0 times 10 to the 4th moles of C12H22O11. Okay. Then the next part, we start with the same thing, 1.4 times 10 to the 5th moles of the C6H8O7. This time we're looking for the ratio for water. So when I go look at my formula there, it is 4 waters for every 2. So, oh, well, sorry, I'm looking at how much I'm needing. Forgive me, I'm looking at the wrong number. How much I needed to start with. Sorry about that. It is 1 of the water for every 2 of the C6H8O7. Make sure I'm looking at the right side because it said reactant. So 1 mole of the water for every 2 moles of C6H8O7. And so that would be the same answer. Let's just make it 7.0 because I already have multiplied that. Okay, so there's 1, 2, and we have a third part. So the third part is finding O2. So we start in the same place we started. And the O2 has 3 of those for every 2 of our citric acid, 3 for every 2. So we're going to put our 2 citric acid on the bottom. And our 3 moles of oxygen on top. And so we'll take that 1.4 times 3 divided by 2. And the answer ends up being 2.1 times 10 to the 5th moles of O2. And that is on your own 6-3.